To honorable instructors and our beloved classmates, good morning, good afternoon, good day, and good night, wherever you are. On this opportunity, we would like to presentate about end semester final project based learning. And title is BOPA, Bonceng Operasional Penumpang Anti-macet. Well, before that, let me introduce ourselves first. My name is Absar, then Mira, then Nofri, then Dwi. We will talk about the end semester final report project based learning. Next. So, we're going to talk about application overview. From prototype to production, BOPA is live. BOPA has the background problems. There is the number of vehicles in Batam reached approximately 1.09 million units Korlantas Polri April 2025. With many vehicles, campus parking space is limited. In case informal ride sharing is not efficient. So BOPA has solution. There is one, exclusive Polibatam community with verification. Two, transparent one-way route matching. Then to deployment status, we have the backend REST API Laravel monolith. Second, mobile client is distributed as manual application. Then third, current operational cost estimate 210,000 months rupiahs. Target reach for the development BOPA, we are target 6,000 users. There is 50% of to 12,000 Polibatam community members. Initially focusing on 480 TRPL students as early adopters. Next. So user adoption and real usage data. Who is using our application and how? Status, BOPA is in the limited soft launch phase. Full-scale user data retention active sessions is still being collected along with the hard launch to all TRPL students. There is 480 TRPL students focused on early adopters, 100 plus early registrants at the pre-launch stage, 33 usability test response remote via mail, 6 early registrants at the pre-launch stage. First transaction target soft launch TRPL 6.8. The target segmentation, there is ages 17 until 50 years old, active students, lecturers, and campus staff, service area Polibatam environment and around Batam Center, behavior, frequent short distance trips, prioritizing speed, safety, and cost effectiveness. So we have a real persona. There is a Novita, 20 years old. There's a passenger. So she doesn't have a vehicle, struggles to find affordable and reliability daily transport to campus. And then we have Atala, 20 years old, as a driver. His own cars and motorcycle with 2 empty seats, wants to offset fuel costs and reduce traffic impact. Next. Tech stack and infrastructure, architecture and production. So the infrastructure that we have at BOPA is a share hosting with cPanel and Rumah website, and then SSL active via cPanel, database MySQL and framework Laravel. Change evaluation from the design versus implementation. For the backend, Python Laravel, PHP monolith for a stronger structure as a feature complexity increases. Deployment migrated from localhost Ngrok to share hosting cPanel for stable 24/7 access, eliminating dependency and temporary tunnel to URLs that change with every development session. Database remains MySQL throughout with connection configuration adjusted for the share hosting production environment. Next. For tech stack innovation, emerging technologies apply, not just explode. In production, explore in progress with BOPA have a Kotlin and Jetpack Compose for the mobile application, then Laravel PHP monolith REST API, Tailwind CSS for admin panel, MapLibre and MapTiller beta open source, MySQL GWT and OAuth 2 for Cloudinary, Selenium for automated testing plan. For the integration challenges and fixes, the laptop cannot run the application stably. Testing is moved on Android device directly. For the performance metrics, load test on monolith architecture, there is a result 300 sample requests, error rate to 26% throughout 1.8 requests per second with high variability in response time. For production deployment lessons, PHP version mismatches between local development and production. Example, framework requiring PHP version 8.2, while the server default to 7.4. Must be resolved before deployment, silent incompatibilities, and cause failures that are hard to diagnose without CLI access. Next. All right, this is the applied research and literature for Absar. We're gonna add into the semester 7 that we are to get a seminar proposal. And the title is Adding Mango Maturity Detection Feature to the Clavo application for using efficient Light 2 with USB webcam on Android devices. For the abstract, there's a Clavo Klavu has a website for detect.id, is an Android-based real-time detection platform using efficient Light 2 model through an external USB webcam via USB OTG. For the methodology, I use the research and development framework adapted from 2015. There is a four phase: phase 1 define, phase 2 design, phase 3 develop, phase 4 testing. And the contribution, the first integration of Mango maturity detection, there is three classes, including the RIP, unRIP, and rotten into the Klavu platform. For the research question, there's a three research question that we're gonna have make this a fundamental to get the possibility as a seminar proposal. And the model evaluation completed, there's overall accuracy 95.56%. There's a 43 per 45 correct, weighted average F1 0.98. For the ongoing work, real-time file evaluation with domain prediction sequeners with stage 2, quantitative regression test for Cengkeh and Matua model stage 3, and finding sections is stage 4 for discussion, limitation, and conclusion. Next.
So this is my research battle for me. I was implementation context when Backend use WebSocket in BOPA. So in BOPA, we only use a static net column for driver passenger communication. So this research implements WebSocket in the BOPA in object feature to provide persistent full text communication between the client and server through a single TCP connection. The methodology I use is KSIG for performance testing and black box testing conducted to validate the functional requirements of the context-aware system, including send and receive message feature. The contribution is providing performance evaluation data for WebSocket. The research question is, how is WebSocket implemented in chat feature of the BOPA application? Second, how is the performance of WebSocket in terms of latency and reliability under multi-user condition? The current status is the implementation phase is nearly complete. The project is currently awaiting testing and evaluation.
Okay, this is applied research and literature for me. This research compressed the spherical law of consciousness and Haversine algorithm for determining driver distance in the BOPA ride-sharing system. The motivation behind this study is that accurate distance calculation is essential for selecting the nearest driver, while the current BOPA system uses the SLOC. Previous studies suggest that the Haversine algorithm might provide better accuracy for short distance calculation. To evaluate this, a controlled experiment was conducted using a synthetic GPS dataset. Both algorithms were tested with identical coordinate inputs and compared against geodesic based on the ellipsoid as the ground truth. Their performance was evaluated using MAE for accuracy and execution time for computational efficiency. The goal of this research is to identify the most suitable algorithm for future implementation in the BOPA system. Next.
So this is our final literature, now 3. So he is adopting microservice architecture with load balancing mechanism to enhance scalability and API availability on the BOPA. So BOPA application paths relate to single point of failure and limited scalability in managing traffic spikes within the campus community. This research transformed the system architecture from a monolithic model to microservice to decouple service models and implement engines-based load balancing to distribute traffic loads efficiently. The methodology is research and development. The contribution is system architecture capable of withstanding traffic spikes during peak campus hours while demonstrating the effectiveness of eliminating single point of failure through the implementation of load balancing mechanism. The research question is first, how can a microservice architecture with a load balancing mechanism be designed and implemented to overcome performance bottlenecks in the BOPA application? Second, to what extent can the transition from a monolithic architecture to microservice improve scalability and API availability under peak traffic conditions? The current status is the project is currently in the implementation phase of engines configuration and load simulation using Apache Geometer to conduct system performance testing in handling concurrent requests from 250 virtual users. So this is our business model market section. Our unique value proposition: first, time and cost efficiency, trusted platform, schedule flexibility, contribution to carbon emission reduction. We have revenue model 3 phase: first, commission; second, premium; third, scale. We have break-even point 100 trip per month. As you can see, our operational cost per month is 210,000 rupiah. Next is marketing and user acquisition. We have 4 phases: first, pre-launch; second, soft launch; third, hard launch, and fourth, retention, and next step. So our brand identity is quite clear. We have, like here, right, sharing campus BOPA Solusinya. Our positioning is internal campus transportation application that is safe, fast, and reliable to support the mobility of the Polibatam academic community. We also affordable and exclusive. Next will be explained by my friends, Ngrok.
Okay. During the development process, we encountered several technical challenges. First, the system experienced unstable access to Ngrok limitation. To address this, we migrate the backend to a VPS with a permanent domain. Second, the manual verification process for user identify and physical was time-consuming. Therefore, we improved the workflow by integrating the verification process into the backend. We also found that the authentication endpoint become slower under high request load. This issue has been identified and is included in our short-term improvement roadmap. In terms of project progress, several implementation plans changed during development. Next. This slide summarizes our team's contribution and the key lesson we learned throughout the project. Its member was responsible for different modules, including backend development, web administration, mobile development, authentication, and algorithm research. During the project, we faced challenges such as adapting to new technologies, integrating multiple systems, and managing time effectively. From this experience, we learned the importance of sprint-based development, continuous communication, and early testing to reduce issues during the implementation phase. Next. In conclusion, our team successfully developed the core features of the BOPA system, including user authentication, ride-sharing functionality, and supporting research module. Throughout this project, we learned that selecting the right technology, maintaining effective communication, and performing early testing are essential for successful software development. Moving forward, our short-term term focus to improve payment integration, notification, and application performance. In the long term, we aim to expand BOPA to other campus and integrate sustainable ability for features to support general transportation.
All right, I think that's all for our presentation. Thank you very much for your kind attention. Good morning, good afternoon, good day, and good night, wherever you are.